This is the Beverage Density Lab Sugar Content Analysis Procedures. The purpose of this experiment is to determine the percent sugar content in beverages. The density of 5 sugar reference solutions will be measured in Part A. The reference solutions contain known amounts of sugar between 0 and 20% and have been dyed with food coloring to make it easier to tell them apart. Their densities will be plotted on a graph to obtain a calibration curve of density versus percent sugar concentration. In Part B, the densities of 2 beverages will also be determined, and the calibration curve will be used to find how much sugar they contain. The results will be compared against the information provided on the nutrition labels for these beverages. Although the materials in this experiment are considered non-hazardous, follow all normal laboratory safety guidelines. Always wear chemical splash goggles when working with glassware and chemicals in the lab. The food-grade items that have been brought into the lab are considered laboratory chemicals and are for laboratory use only. Do not taste or ingest any materials in the chemistry laboratory. For this experiment, you will be using the procedure that has been altered in your lab manual. When writing up your pre-lab, please find the section that states changes to beverage density procedure and follow those steps rather than the ones that are listed in your lab manual right after the introduction. The page looks something similar to this. Also use the modified data tables for Part A and B that are found after the Changes section. The first step to this experiment is to obtain your supplies. You will need pipettes, which are the glass tubes which are pictured below, pipette fillers, which are green, beakers, 3 of them, a 50 milliliter beaker, which you should use to transport the sugar solutions to and from your lab bench, a 100 milliliter beaker, which you will use to make all measurements on the balance, and a 250 milliliter beaker, which will be used to contain your waste during the experiment. When obtaining the pipette, fully drain it from the bin that it is stored in, because currently they are filled with water, and it would be very messy and not safe to walk through the lab with dripping pipettes full of water onto the floor. Next, weigh and record the mass of an empty 100 milliliter beaker. Record this information in your data table in the first column, as indicated in this figure. Then you will use a pipette to obtain 10.00 milliliters of solution. A pipette is a very different piece of glassware compared to anything you've used before. The 0 marking is at the top of the device. When using the pipette, you use a pipette filler, which goes on the end of the pipette like so. Use your thumb to draw liquid up the length of the pipette. As the liquid fills up the pipette, draw it up to the 0 marking on the pipette. Once you have 10 milliliters of liquid, which will be indicated by the 0 milliliter mark, allow the liquid to drain into the receiving beaker, which is the 100 milliliter beaker. Measure and record the mass of the solution once you have placed the 10 milliliters of liquid into your beaker. This should be done at your lab bench, and then the beaker should be walked over to the balance. Record the mass of the beaker with the sample in it in this column of your data table. Repeat the same process for each solution. Go in order from the least concentrated to the most concentrated sugar solution. Then for part B of this experiment, you will do the same procedure, only instead of sugar solutions, you will use soda that is provided. Make sure that you record which beverage you are measuring, the mass of the empty 100 milliliter beaker, and then the mass of the beaker plus the soda in the data table. When you are finished with this, rinse the pipettes with water and then return them to the tub where you got them at the beginning of the experiment. Make sure that you wipe down the lab table and rinse out the beakers that you used so that when you put them back in your lab drawer, they won't be sticky for the next time that you use them. Be sure to follow all post-lab procedures, including graphing and answering post-lab questions that your teacher indicates.